Solving absolute value inequalities. Let's recall some notation. Not equal to is the equal sign with a line through it, but the bottom four symbols are the ones we'll be focusing on in this video. Okay, definition. An absolute value inequality is an inequality with at least one absolute value expression. The solution to an absolute value inequality can be written as a compound inequality. And please note that the graphed solution region or regions of an absolute value inequality may resemble a line segment, one ray, two rays, no solution, or all real numbers. We'll get started with our first example. So we're asking you to solve or find the x's which make this sentence true. The absolute value of x is less than 6. The solution set is all real numbers whose distance from 0 is less than 6. Therefore, x is less than 6 and x is greater than -6. But we're thinking about the places where these regions overlap. So let's take a closer look. X is less than 6 is represented by this orange line. X is greater than -6. But where they overlap is the solution to the absolute value inequality. So that section from -6 to +6. And the solution set is denoted this way. We say -6 is less than x is less than 6. Let's do another one, but this time with the greater than. The absolute value of x is greater than 6. So we want the numbers whose distance from 0 is more than 6. So can you picture what that would look like on a number line? We want x is greater than 6 or x is less than -6. So anything in the pink region is a solution and anything in the orange region. Both of them are solution regions. And to denote that with symbols, we do need the word or in between the two inequalities. All right, so here's one where we have to first isolate the absolute value term by subtracting 7.4 from both sides. And now we're saying the solution would be any number that is less than or equal to 2.4 units from 0. And again, there'll be two pieces joined with the word and because we're talking about the intersection of those two sets. In words, we say x is between -2.4 and 2.4, including the endpoints. That's why the endpoints are colored in. Let's take another example. The absolute value of x minus 5 is less than or equal to 3. Now I want you to realize there's two approaches and both are equally valid. We'll do the first one as we've been doing it with the word and. We say x minus 5 is less than or equal to 3 and x minus 5 is greater than or equal to -3. Let's solve both inequalities by adding 5 to both sides. And here we have, picture the graph of this would go from 2 to 8, everything in between, including the endpoints. But some people prefer to solve this inequality using a symbolic way of saying and. So we say -3 is less than or equal to x minus 5 is less than or equal to 3. Let's add 5 to all three sides. And this is also saying x is between 2 and 8, including the endpoints. So that's with the less than. Here's one with the fraction and the greater than. First, isolate the variable, add 4 to both sides, multiply by 5 to both sides, And this is going to be a two-piece solution region. X will be greater than 10, that's one part, or X is less than negative 10. Open circles at 10 and negative 10. There will be a couple of special cases that we want to pay attention to. Here's the first one. Solve the absolute value of x plus 6 is greater than 1. You may not realize it's a special case at first glance. You're going to isolate the absolute value term. But here's where you'll take a second look, because there's something about that negative 5 with the absolute value term that should stand out. We know absolute value is always positive. Therefore, the solution to this inequality is all real numbers. The absolute value of all real numbers is greater than negative 5. So when you start with your number line, what you want to do is shade that in another color or darker, and with symbols you can say x is a member of the reals. Any real number solves that original inequality. Let's take another special case. Here we have negative, the absolute value of 2x minus 3 plus 4 is greater than 9. Isolate the absolute value term first. So we're going to subtract 4 from both sides. Now we want to divide both sides by negative 1, but when we do, remember, we switch the direction of the inequality. And again, something about that absolute value expression coupled with that negative ought to make you kind of think about this. This is saying the absolute value of some expression is less than negative. Trouble with that is absolute value is never negative. Therefore, there is no value of x, which when I substitute in to the most recent expression, that is, I multiply it by 2 and I subtract 3, then I take the absolute value of x, no solution will make that true. And we denote this with empty braces, or we do the null set like that. So they were absolute value inequalities we were considering today.